So for tangent of S, you should have gotten 5 over 12 or 0.4167. For the tangent of R, you should have gotten 12 over 5, which is 2.4. How'd we do? Does it make sense after I went over it? Okay. Next one, there is an error here. Actually, someone pointed out there's actually 2 errors here. What is one of the errors, Juliet? Very good. The ratio is incorrect. What should the ratio be, Juliet? Excellent. It should be 32 over 24, okay? That is the correct ratio for the tangent of K. Does anyone notice the second mistake? Yeah? Excellent. This K should be a capital K, okay? Because remember, when you're talking about an angle, it should be a capital letter because it's referencing a point. How are we feeling? Any questions on the warm-up? Talk to me. If it was easy, I need you to give me a nod. The homework was easy too? All right. Tangent yesterday. Today we're learning about 2 more ratios. They are sine and cosine, okay? Your sine and cosine ratios, okay? The sine ratio of an angle is you're now accessing still the leg that's opposite. So underline the word opposite. But now your denominator is which length? The hypotenuse. So guys, tangent did not involve which side? Hypotenuse. Sine and cosine are both going to involve the hypotenuse. And for the hypotenuse in sine and cosine, it will always be in the denominator, okay? Now for cosine, it's the same ratio except they're changing and they're accessing the leg that's adjacent to your angle. And then they're putting it over your hypotenuse, okay? So if we're looking at angle A, right? Angle A is up there at the very top. Guys, what side is opposite the angle A? Lowercase a. Do you guys see that? So that's the leg that's opposite capital A, the angle. What's the hypotenuse? C. So your ratio for sine of capital A is little a over C. Do you guys see that? Now, cosine says don't access, your numerator is not going to be the opposite side. It's going to be the adjacent leg. What is the adjacent leg to angle A? B. Now, you guys, C is also adjacent. Do you guys agree? But why is C more special? It's the hypotenuse, okay? So when it references adjacent, remember it's talking about a leg. So adjacent would be B, and your hypotenuse is still C. So your ratio for cosine of A is B over C. Let's take a look at the sine of B. So go to angle B. What side is opposite angle B? Little b. So your ratio for sine of B is little b over C, because C is the hypotenuse. Okay? Check it out. What do you notice is the same between all 4 of these ratios? C. The hypotenuse is always the denominator. Highlight that, guys. Okay? That's very important. All right, now you're probably wondering, okay, this is a lot. You have to remember tangent is opposite over adjacent, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. There is a very nice, convenient method to remembering all of this, and it's called SOHCAHTOA, okay? So on your next slide, I'm going to introduce you to SOHCAHTOA, okay? So, okay, SOH is your first section, okay? The S, what do you think the S stands for? Sine, very good, S-I-N-E. So your sine is always going to be your O over your H, where O stands for? Opposite, very good. And h is your hypotenuse. What's that? Each of the letters stands for a different side. Very good. So when we're writing sine, we're always going to write that sine is the equivalent of O over H, where opposite, or O stands for opposite and H stands for hypotenuse. Okay? What about cosine? So for cosine, that's obviously our C. The A stands for adjacent. Very good, Hannah. So ADJ, I'm just going to abbreviate for adjacent. And the H stands for hypotenuse. So when we're writing cosine, it's going to be A over H, adjacent over hypotenuse. And then TOA, what does the T stand for? Very good, tangent, T-A-N. O is opposite, I'll put oppo, and A is adjacent. So for tangent, it's going to be O over A, opposite over adjacent. So, ka, toa. And then the last thing was there's this little question in the bottom right corner. It says, what is the same about the sine and cosine ratios? We did touch on it a second ago. Very good. Hypotenuse is always the denominator. So just put hypotenuse is always denominator. What ratio does not use the hypotenuse? Tangent. Very good. Okay. Cool. All right. This thing. So let's go ahead. I want us to try to express the sine of capital A, the cosine of capital A, and the tangent of capital A. So let's write out our ratios. Our first one is SOH for so. That means that the sine of A is going to be the opposite side over the hypotenuse. All right, find capital A on your diagram. That's right here. What side is opposite capital A? 3. So we're going to substitute wherever we see O, we're going to put a 3. And what is the length of my hypotenuse? Very good. My hypotenuse is the 5. There should be a 90 angle there, by the way. So it should be 3 over 5. Cool? Kind of? Okay. Cosine, right, is so, ca, C-A-H. So I'm going to write cosine of A is the equivalent of the adjacent over the hypotenuse. Now, when we're talking about the adjacent, can the adjacent side be the 5? Why not? That's the hypotenuse. When we're talking about adjacent, it's always referencing a leg. So which leg is adjacent to angle A? 4. So this is going to be 4 over 5 still, okay? Remember, your sine and your cosine ratios should have the same what? Denominator. Very good. And that should be the hypotenuse. And lastly, TOA for tangent. T-O-A. So the tangent of A is going to be what ratio? 3 over 4. Very good, Carson. 3 over, well, I should write it down first. It's going to be opposite over adjacent. And you are correct. It's 3 over 4. Okay? I would like you guys, and I want you, if you make a mistake, it's totally okay. But I want you to try B. I want you to try all 3 of them for angle B. Trust you. All right, German, what'd you get for the sine of B? 4 over 5. Do we agree with German? Yeah, buddy. What about the cosine of B? 3 over 5 is correct. Guys, what time is this class over? 25? Okay. And then the tangent of B. German. What?
That's my dual partner right there this year.
There he is. 3 for 3. Give it up for German. Give it up for German. All right, how'd we do on this one? Does it make sense? A little bit? Yeah, what's up, Dylan?
Why is sin A is equal to cos B, and sin B is equal to cos A?
I mean, it's like so amazing that you asked that because that's literally my next slide. So, Dylan asked, why are the sine of A and the cosine of B always equal to each other? And it's because A and B are complements. What does it mean to be complementary? They add to 90 degrees. So if you add to 90 degrees for two angles, the sine of one of those angles will always be equal to the cosine of the other angle. Okay? So what that means is, for example, if we have the sine of 60 degrees, we can say that's equal to the cosine of what angle? Of what angle? 30 degrees. Because 60 and 30 add up to 90. Okay? As long as your two angles are complementary, the sine of one of them will be equal to the cosine of the other. What about the sine of 45 degrees? That would equal the cosine of 45 degrees. Let's say I had the cosine of 32 degrees. That would be equivalent to the sine of what? 58 degrees. What?
So you go up to 90?
Yeah, they have to add up to 90, okay? Now, what if I did the cosine of 42 degrees equals the sine of 42 degrees? Are these going to be the same? No. Because are they complements of one another? Like, do they add up to 90? No, what do 42 and 42 add up to? 84, okay? So it's not 90. Yes, Sienna.
So if you know one, you don't really have to find the other. Because you can just like...
Kind of, yeah. Mm-hmm. Now, why is this applicable? Well, you guys agree in a right triangle, one of your angles is what? 90. So wouldn't the other two angles always have to add up to 90 degrees? So that's why it's cool for sine and cosine, okay? So your sine of one angle will be equivalent to the cosine of the other angle in a right triangle, okay? All right, let's get a little bit proficient using our calculator. So take out those calculators. I need you to find the sine and the cosine buttons on your calculator. I would like you to plug in the sine of 30 degrees and tell me what you get. 0.5? You got 1/2? That's the same as 0.5. Okay. 0.5. Bingo. You got what? Click mode. Then I want you to try the cosine of 42. Cosine of 42. I got 0.7431448255. Let's say it asked us to round it to the nearest hundredth. Where's the hundredth place? 0.74. Because the hundredth place is the second decimal, so it would be 0.74. For letter C, guys, we have the sine of some unknown angle equals 0.1045. What do we do here? Sophia?
I have to put it in the negative.
Very good. It's called the sine inverse. So it's sine -1, and then you plug in 0.1045. You should get approximately 6 degrees. I think it's like 5.99. Correct. So then round it to 6 degrees. And then if you do the cosine inverse of 0.9659, you should get around 15 degrees. Approximately 15 degrees. You should be checking that your calculator is getting the same results. If you're not, you might be in the wrong mode and I can help you after, okay? Just put a star next to this slide if you're getting different answers. Okay, we're going to do one more example and then we'll call it. Last example, guys. Find the values of x and y to the nearest integer. So let's take a look. Let's try to solve for, what's an integer? Guys, what is an integer? It's like a whole number, right? So it shouldn't be a decimal. You're going to round to the nearest whole number. Let's say we wanted to solve for x first. What ratio could we set up to solve for x? Nick? I couldn't hear you. X over 1,000, okay? So x over 1,000. What ratio is that? Let's look at 28 degrees, right? X is what compared to the 28? It's opposite. And the 1,000 is my hypotenuse. So which of my three ratios involves opposite and hypotenuse? Sine. So if we took the sine of 28 degrees, do you agree that should be equal to x over 1,000? Perfect. Now, be careful here. How do I solve for x here? Multiply both sides by 1,000. Very good, Ronnie. Multiply both sides by 1,000. Multiply this by 1,000. And you're going to get x equals, I forgot what it was. I think it's like 400 and something. Sine of 28 times 1,000. 469. Who had a question? You have a question? Go ahead. Are you using... Okay, guys, start packing up because the bell's going to ring. We'll finish these notes next week. Angle X. Like if we were to talk about just this angle X, how does the 18 relate to X? Ronnie? It's the opposite leg. Very good. Let's put an O over there. And then the 30 is the other side that we're given. What does the 30 represent? The hypotenuse. Okay, now you're tasked with the question, which one of my three trigonometric functions should I use? Sine, cosine, or tangent? Sine. Why? Thank you. Sine is opposite over hypotenuse, right? Because it's SOHCAHTOA, correct? So what we need to use here is the sine of our angle. What's our angle? X. So we're going to say sine X equals what ratio? 18 over 30. Now, we need to find X. Who remembers what I do in this scenario when I have a trig function of an unknown value equals 18 over 30? Cody? No. Do not divide by 1. That's if... So, Cody, we would do that if we knew what the angle was and we didn't know what the 30 was, if our x was where the 30 is. Hayden, do you remember? You could simplify the 18 over 30. What are 18 and 30 both divisible by?
Wait, don't you have to multiply the 30 and bring it over 6?
No. We're not going to multiply by 30 either. We can divide them both by 6, yeah. So that would turn this into not 18 over 30, but 3 over 5. Very good. So we have sine of x equals 3 over 5. Nobody remembers what to do when your x is next to your sine function? Daniel? Yeah, we have to isolate the x, but how? How is the question? Divide by sine? No. Yeah? No. Yeah?
Sine -1.
Thank you. It's something called the sine inverse. Do you guys remember that? So the sine inverse, the reason this is helpful is because what does the sine inverse do when you have a sine function? The sine inverse is the inverse of the sine function. So when you take the inverse of the sine function, they cancel out. So now on the left side of my problem, what do I have? X equals, and I have sine -1 of 3 over 5. And that second part, what's on the right, you just plug into your calculator. So take out your calculator, and I want you to type in the inverse sine of 3 over 5. So you should have gotten 36.9. What units does this take? What units does it take? Degrees. Why degrees? It was an angle. Very good. Okay. We did actually round it. Correct. You should have gotten like 36.86 something. But always round to the nearest tenth if it doesn't say specifically. Okay. Oh, this one said to the nearest degree. Excuse me. So what should this actually round to, guys? It should be 37 degrees. Thank you, Diana. This one should actually be 37 degrees, guys. 37 degrees. Any questions on that? All right, this one doesn't relate to this problem. Please add another slide in here. I just want to do an extra problem with you guys because I don't know if we're all 100% on this one. Let's say we had the cosine of x equals 5 over 2. I'm sorry. Make it 2 over 5. Okay, so just so we're clear, x is next to cosine. Do you guys see that? So we know that x is going to be an angle, right? Because we take the sine and we take the cosine and we take the tangent of angles. So what do I have to do in order to solve for x here? Hayden? Very good. The inverse cosine. So that's going to be written as cosine -1. Cosine to the -1st power, or cosine inverse. And we take it to both sides. So we're also going to do it to the right-hand side. So now what happens on the left, guys? Very good. Cosine inverse cancels with cosine. What do I get? X equals what? Cosine inverse of 2 over 5. Okay? So go ahead and plug that into your calculators. Let's see what we get. I got 66.4. Did you guys get the same? Yeah. Awesome. And we'll put degrees because we know it's an angle. It'll say on the problem. If it doesn't say for the problem, always just round to the nearest tenth. But if I don't say on an assessment, I won't take off points for what you rounded to. Okay? Are there any questions? Go ahead, set a timer, okay? All right, let's move on to the next one. In this next example, we have a triangle, right? And we're asked to find the measure of the 3 angles and round to the nearest tenth. But what's different about this triangle? It gave me all the sides, yep.
It's isosceles.
It's isosceles. Is it a right triangle? No. But it is isosceles. How did Sophia know it was isosceles? 2 sides are the same. AB is the same length as AC. What do we know about isosceles triangles? The base angles are the same. So what 2 angles are going to be the same, guys? Angle B and angle C. Very good. Now, could we maybe draw something to make a right triangle here? Daniel? Line down the middle. What is this line called?
Bisector.
No. Well, it is a bisector, yeah. It is the altitude. Very good. So going from the vertex on the top down to the base and forming a 90-degree angle creates an altitude. Now, we don't know the length of this altitude right off the bat, right? But we do know some information about it. We now know that the right triangle on the left is the exact same as the right triangle on the right, because this is an isosceles triangle, correct? So what does that make these two lengths if they have to be the same? They're each 2 units. Very good. So let's go ahead. Let's try to solve for angle B here. Okay? And I want us to focus on only the right triangle on the left-hand side. Remember, we don't know the length of that altitude yet. So let's say, okay, let's refer to angle B. What would the 2 be? The length of 2 in relation to angle B. Would it be opposite, adjacent, or hypotenuse? Adjacent. Why? It's next to it. And it's also, is it a leg or the hypotenuse? It's a leg. So this has to be A. Do you guys agree? It has to be the adjacent side. What would the 5 be? The hypotenuse. Why does 5 have to be the hypotenuse? It's opposite the right angle. Very good. So let's put an H there. So now this just became a lot easier. We are looking for the trigonometric ratio that deals with adjacent and hypotenuse. Which one out of SOHCAHTOA? Yep. Cosine. Very good, Sophia. So CAH in SOHCAHTOA means adjacent and hypotenuse involve cosine. So we're going to take the cosine of what? What do I put next to cosine? B. Very good. Cosine of that angle B is going to be equal to what ratio of the 2 sides? 2/5. Very good. Did we just see this problem? All right, how do I solve it? Not the sine. The inverse of what? Cosine. Very good. So take the cosine inverse of both sides. What's going to cancel? Cosine inverse and cos. And I'm going to get B equals cosine inverse of 2/5, which I think we just got was 66.4. Now that we've done that, do I have to do that again for C?
No.
What do B and C have on them? Congruence marks. So what does C's value have to be? C's also going to be 66.4. Now let's make life even easier, guys. Is there a very easy way we could find A? Dylan? Add them and do what? Very good. Subtract it from 180. So let's add B and C together. What's 66.4 plus 66.4? 132.8. And then we go ahead and take 180 minus 132.8. Dylan, why did you subtract it from 180? Very good. They're all part of the same triangle, which is ABC. Okay? And then I think we get like 47.2. And that is the measure of angle A. Questions? Yeah, Ronnie? How did I know that this one was adjacent? Okay, so Ronnie, in every single right triangle, one of your legs is going to be adjacent to your angle. One of them is going to be opposite, and the other one's going to be your hypotenuse. So Ronnie, both 5 and 2 are next to angle B. Do you agree? They're both touching angle B. But why isn't 5 the adjacent one? Because it's the hypotenuse. So then angle 2 has to be the adjacent one, and this altitude then becomes the opposite. So if we knew the altitude, we would use sine, but since we didn't know the altitude, we're using cosine. Okay? Good question. Any other questions, guys, on this one? Okay, let's do the last example, this one. What's your question?
Finding the measure of angle close. Okay.
We're good?
Um, yeah, we're.
Another one. This example, guys, it's much easier, more easily understood. If we look at, go ahead, you can put a star next to this one. It's basically the same as the next slide.
There's
Can you go back to the exam? Can you go back to the last example you told me?
Okay. So yours are flipped. The next problem. Okay. So you guys see this one first? Okay, then let's do this one. So we're finding the sine and the cosine of 45 degrees, but we're using special right triangles. So remember, if you're taking the sine or the cosine of 45 degrees, you're dealing with a 45, 45, 90, correct? And in a 45, 45, 90, you know that if your leg was A, so if A is equal to 1, then your hypotenuse is just the square root of 2 times A. But if A is 1, then your hypotenuse just becomes the square root of 2. So now let's look at this angle and let's say, okay, what would the sine of 45 degrees, what ratio would that give me? What is sine? Yep. Sine is in SOHCAHTOA. What two letters go over one another? O over H. In other words, opposite over hypotenuse, correct? And in this case, the side that's opposite is how long? 1 over, what's the hypotenuse? Square root of 2. Very good. Now, guys, I noticed this on the test, okay? When you have a radical in the denominator, okay, you're going to see this going forward. It should have been something that was taught to you in algebra. You have to rationalize, what's called rationalize your denominator. So write this down again with a little star. This is called rationalize denominator. So it's 1 over the square root of 2. And how we rationalize the denominator is you multiply by whatever radical is in the denominator. So we're going to multiply both the top and the bottom by the square root of 2. All right, and remember, when you multiply fractions, you just multiply straight across. So guys, what is 1 times the square root of 2? 1 times the square root of 2, or just the square root of 2. Do you guys agree? Because 1 times anything is just whatever that thing was. Over, what is the square root of 2 times the square root of 2? It's 2. It's the square root of 4, which we know is 2, correct? You guys with me? So now, have I gotten rid of my radical in the denominator? Then I'm happy. This is my answer, okay? Now, just so we're proficient with our calculators, I would like you to take two things and plug them into your calculator. I want you to plug in the sine of 45 degrees and let me know, did you get 0.707? No? If you got radical 2 over 2, then your calculator is doing that thing where it's just writing it as a simplified radical. Press the 2 arrow buttons that are pointing away from each other, okay? And then I want you to type in the square root of 2 over 2. And you should see they're the exact same answer. For both of these, you should get 0.7071067812. Or 0.7. Okay? Now, what's cool is that for cosine, right, we don't actually need to do it all over again. So I told you guys, I think it was on Friday, right, that the cosine of an angle that's complementary, to the sine of another angle will be the same. Do you guys agree? So if I had like the sine of 30 degrees, that's going to be the same as the cosine of what angle? 60, because as long as they add up to 90, they should be equivalent, right? Ronnie, put it away. So do you guys agree that 45 and 45 add up to 90? So what would the cosine of 45 degrees be? The same as the sine of 45 degrees? Cool? So if we knew that the sine of 45 was the square root of 2 over 2, isn't the cosine of 45 just the square root of 2 over 2? Feel free, right, to do it for this triangle, right? You'll get the adjacent side, which is the 1, over the hypotenuse, which is the square root of 2. So you're going to get 1 over the square root of 2. You're going to rationalize the denominator, and you'll end up with the exact same thing. Okay? Now, the second one, it says we're now dealing with a 30, 60, 90, because it says the sine and the cosine of a 30-degree angle. Okay? So let's take a look down at our diagram. Let's focus on this angle. And let's go ahead and find the sine of 30 degrees. Hayden? It's 1 over 2. Very good. Because we have to take the opposite side over the hypotenuse. Excellent. So it's 1 over 2. How do I represent 1 over 2 as a decimal? 0.5. Very good. I would like you to plug into your calculators the sine of 30 degrees. See what you get. All right, then I want us to do the cosine of 30 degrees. But cosine does not deal with the opposite leg. What does it deal with? The adjacent leg. Which leg is adjacent to the 30? The square root of 3. So we're now going to say the square root of 3 over 2. And I would like you to plug into your calculator both the cosine of 30 degrees and the square root of 3 divided by 2. And you should get something for both of them close to 0.866024-ish. Or 0.9 if you're going to round it. Okay?
That's the answer.
Yeah. So I want you guys to be familiar with both the radical expression and the decimal. Okay? I want you guys to be familiar with both. Any questions on this example? Make sure you set a timer. Okay. Is the next slide elevation? Bingo. Or depression. Perfect. Okay. Guys, we're going to pause here. Do not turn these in again. The only thing I need you to do is an angle of depression, right? What does it mean if you hear the word depression? Sadness, down, right? It's going, and you can use that to help you, right? An angle of depression, right? It's going to be going down. It's not like a positive thing. It's a negative thing, right? So our angle is going to start at a horizontal line and go downwards, right? And so you're going to see like a horizontal line, but it'll be below ground or below that horizontal line, okay? So like some examples could be like what's the slope of your ski slope is like 21 degrees at an angle of depression. Because right, when you're skiing, you can only go forward if it's like downwards, right? So it's going to be an angle that's shifted downwards. It's hard to describe without a picture, but it'll make more sense in the next example, okay? And it's typically also, if you want to underline this, it's typically related to a line of sight, okay? So if you're looking down a canyon towards like the river below or something like that, okay? All right. So in this next example, you are skiing on a mountain with an altitude of 1,200 feet. The angle of depression is 21 degrees. Find the distance x you need to ski down the mountain to the nearest foot. So if we're looking at this diagram, right, you draw a horizontal line from where you're at, and the angle of depression going down is 21 degrees. Do you see how the angle of depression is different than the angle of elevation?
Yes.
An angle of elevation, if you want to write that an E in there, would be something like this, where it's starting at the ground, but you're looking up, okay? Angles of depression are from where you're at going down, okay? So it's 21 degrees, and we know that you are currently 1,200 feet in the air, or above ground. How far do you have to ski to make it to the bottom of the slope? That's your X value. What could we set up here? It's not going to be tangent. So it's going to be cos. It's not going to be cosine. Look at the 21. Go across from the 21. What is this 1,200? Opposite, adjacent, or hypotenuse? Opposite. What is the X? Hypotenuse. What involves opposite and hypotenuse? Sine, because it's SOHCAHTOA, right? So we're going to say the sine of what? What? 21 degrees equals 1,200 over X. Do you guys remember what I do next? Juliet? Very good. Make it into a fraction, put it over 1, and then cross multiply. So you're going to multiply X by the sine of 21 degrees equals 1,200 times 1, which is just 1,200. Remember, I'm still solving for X. Who remembers what I do next?
Divide.
Good, Cody. Divide by what?
Sin 21.
Divide by the sine of 21 degrees. And in your calculators, plug in X equals 1,200 divided by the sine of 21 degrees. I got 3,348.5. And this was what units? Feet. Okay? What questions do we have on this example?
Cosine is when it's opposite and right next to it.
No. So cosine we would use, you wouldn't have this opposite side, right? You would have the adjacent side, which would be this one, and the hypotenuse, okay? What other questions do we have? Was that a hand, Benji, or just stretching? Okay. All right, guys.